We have Parthiban and Ravi Prakash. So Parthiban received his bachelor's degree from Dr. NGP IT College in 2019. He started his career in Propel Industries and worked on various projects like rock splitter, IoT automation in hydraulic power pack of cone crushers, hydraulic adjustment in jaw crushers, crawler mounted crushing equipment, single speed and dual speed machines, and asphalt paver, etc. Throughout 6 years of his career, he has worked with heavy engineering hydraulic systems and its development. Ravi Prakash received his bachelor's degree from KIT Coimbatore in 2019. He started his career in HYV Kimber as design trainee, where he has worked with various projects like development of mechanically operated pressure regulating valves, hydraulic pump service and testing, and moved on to Propel Industries, worked with various hydraulic projects like rock splitters, crawler mounted crushing equipment, single speed and dual speed machines, development of hydraulic cylinders, etc., taking care of hydraulic hose routing in mobile and semi-mobile equipments. So welcome Parthiban and Ravi Prakash, up to you.
Very good evening to all present here. Since we are heading to end of the day, here I am going to discuss about benefits of proportional control systems in crawler mounted machines. Hope the proportional control valve systems are not new to everyone. Here I am going to discuss about when we are having the proportional control systems for the crawler mounted machines, what are the advantages we are having and how it is utilized in special machines in crushers. So, this paper abstract presents soft start methodology for crawler mounted machines and how it was operated with the proportional control valves with the risk-free operations, and how the proportional control valves overcome with the conventional methodal drawbacks, and the specific papers discuss about advantages of having manual override in the proportional control valves and advantages of hydraulic component failures to overcome those conventional methods. Here, this is an overview of how the proportional control valve systems located in the machines how it's operated. In basically, the engine is coupled with the alternator to provide the power to run the electrical motor for getting the hydraulic system flow to drive the traction drive with the help of proportional control valves. And hope the proportional control valves basically work with the PWM method. For controlling the actuator speed, we are using proportional control valve. It seems like a conventional valve, but here the difference means having the solenoid valve in it for varying the voltage to move the spool for getting the different actuator speed when we are controlling the input voltage. Based upon the flow handling, here the proportional control valves may and may not require the pilot pressure to move the electrical valves. Since the PWM means pulse width modulation, here the pulse width modulation is an efficient technique to control the proportional control valve with the help of input current. There are two graphs which shows how this conventional solenoid works and the proportional solenoid works. Here, when the conventional solenoid works based on the logical inputs, when we are providing the inputs to the conventional solenoid, it's moved to one position to another position as a logical value. In the proportional, we can regulate with the help of PWM to regulate the spool movement. And there are, in proportional control valves, there are two different types of solenoid valves available. One is on-off and another one is proportional. In the proportional itself, we are having the two different features with the proportional control valves. Those are with LVDT transducer, without LVDT transducer. Here, the conventional on-off typically shows how it functions. This is a complete section of on-off solenoid valves. Here the master spool was located, where the feedback will be getting from the LVDT with the on-off type. When we providing the electrical signal to the Actuator, it's directly converting to the master spools to move, shifted the one position to another positions. But typically proportional solenoid valves having the advantages of LVDT, it's providing the feedback to the master spool where it was located, whether in either in a side or B side. Based upon that, the master spool will be moved from one position to another position. For the moving the master spool, we can varying the electrical current from this electrical section. Here the typical PWM working control valve, how it works and what are the control methods typically involved in the PWM. Microcontroller works the electrical signals to solenoid and direct it to the main spool. Here the main current input voltage will be given to the microcontroller. Based upon the power supply, it moves the main spool with the help of microcontroller. The moment the spool moves, it's giving a signal to LVDT for confirming whether the spool moves or not. Here basically the electronic provides the accuracy. From the electronic provide accuracy, we get the hydraulic provide force. When we are going up with the proportional control valves with the LVDT options, there are significant features for this ramp up, ramp down. When the crawler mounted machines moves from one position to another positions, this will be typically helpful for when the machine starts moving. If you are going up with the conventional method, it starts in a jerky manner. When the car, let me take an example for the car. If you are operating the car with the 0 to 50 gear, the moment the traction moves in a faster manner. But here, if you are going up with the proportional control valve means, we can regulate the speed by accelerating the method. So typically, this acceleration can be done with the ramp up and ramp down. The moment starting and stopping, both the time we can do. There was one more advantages of having with the proportional control valve means fault monitoring system. This fault monitoring system will very helpful when the crawler mounted machines while loading or unloading in the trailer. Those time which will be very well helpful for confirming the whether the system doesn't having the error or not. These are all the supply voltage will helpful for maximum operating ranges. From the operating ranges, this is acceptable range. From 85 to 50%, these acceptable ranges. 50 is a neutral position. From these 50%, there are the working ranges are available. 25 to 75. When the spool position was error available, we can't able to move the machine because the error itself hold the positions. There was an error, we have to check and get back to solution. This is the typical explanation began for the fault monitoring system. The input voltage is continuously monitored. The acceptable signal range is between 15 to 18%, 85% of supply voltage. If the signal voltage goes out of this range, the system will switch it into an error state. If one of the wire to the LVDT sensor or inside the sensor is broken or spool stuck, the system will switch into the error state. This will be typically helpful when the spool was tugged. Those time there is a possibility of machines move in the sudden manner or may not happen. So those time it will be really helpful to review the error state for crawler operations. The spool position must always correspond to the position requested by the input signal. If the spool is 15% further the neutral position, then requested the system detects an error and will switch into error state. And here on to I hand over to my team.
There are some advantages of having proportional system in our systems. While we are using proportional system, which is very much similar to the conventional direction control valve, why we are using direction control valve instead we are using going towards proportional control valve is for precise control we are using that proportional control valve for precise movement. For example, we are saying like if we are moving a crawler for ramping into a ship or any other thing, for precise control that the thing is we are using. Another thing is that it is fault monitoring, like Parthiban already have seen. We can able to get the feedback from the valve in the case of spool stuck or any other malfunction which may happen in the valve. We can get the feedback and we can control the machines which may cause injuries to the operator or any other else. So this is the major advantages of while using proportional control valve. Another thing is that which reduces the wear life of hydraulic components. Basically, why we are saying this wear and tear of hydraulic components. If we are moving a machine at a very high RPM, the chance of hydraulic pressure hitting the hydraulic component is very high. So, in order to reduce the wear life, we are also using these type of proportional valve. So, another thing is that these hydraulic pumps are initially, if we give a high motor power, the chance may be or may not be work. For example, if we give full load to the motor, it can't be capable to pull the 65-ton machines. So we are gradually increasing the speed by regulating the flow. So this is one of the major advantages. And also, if we giving a full flow to the machine, which produces a very much noises, and so that noise will also be reduced. Another major thing advantages is spool with a manual override. The spool which with manual override helps in case of any electrical malfunctions. So at the cases, this manual override will be very much helpful. So which is the most advanced type of valves in the at the market is proportional servo valves, which is very much cheaper when compared to servo valves. So, like already said, there are already in the market we do have two types of solenoid, just on-off solenoid and proportional solenoid. If on-off solenoid is present, which moves the machine without any control, so which will be one of the drawback at the conventional method. So in case of proportional, it won't be there. So that is one of the major advantages. This method will require less filtration when compared to servo. Servo in the sense which makes us very precise filtration technique we are required. So, but in case of proportional control systems, it does not have that such filtration is required. So, in case of manual override, we can able to adjust the flow by limiting the this spool, this lead screw over there. In case of electrical, like already said, in case of any electrical malfunctions or in case of dust entered which may cause the spool stuck, at the time we cannot able to move the machine. So at that case also the manual override will be very much helpful. Okay. So as we have some advantages, likewise we do have some disadvantages also in the machine. So these disadvantages of having that conventional machine is that these are for logically operated. Once zero is for positive operation, and 0 is for negative operation, and 1 is for positive operations, which acts like a switch. So this is one of the major disadvantages while we are proposing towards the proportional control valve, and does not in this sense we don't have any accuracy. The major advantages that we are facing here is that shock, which is very much minimized while we are going towards the proportional control systems. That's it.
Any questions? Yeah, there is a gentleman over there.
Hi,
Sir, excuse me, there is a gentleman behind you who is
hi.
going
This
to
is
question.
Ramakrishna from Epirov. I have one question. So, what will the cost impact on the conventional and this proportional?
The cost impact on the conventional, when we are comparing with the proportional, it's obviously having the quite a impact on the proportional systems. But when we are going up with the proportional control systems, there was a major significant advantages we are having, like risk-free operations and smooth. Because here we are moving the machines having a tonnages of around 65 tons machines. Those are all moves in and out of the in and out of the quarry. So those times these proportional systems will be helpful. The cost impact is might be having.
Not be an issue.
Let me add a little context to what Parthiban said just now. See, this is a crawler machine and it's basically a track-mounted cone crusher or a jaw crusher. So this is a plant that actually moves on wheels. And these plants are sold on a time-bound basis to the customers. So their customers actually rent out the quarry and they have to use it 24/7. So any loss of time in that crusher translates into a huge monetary loss for them. So this delta, what you're talking about in terms of conventional valve and proportional valve, is far more than compensated by the time that is saved. So actually, you can correct me if I'm wrong. The track mounted crusher is costlier than a static plant. But because of this one reason, where the transit within the quarry is
Very much easier.
very simplified, this delta is actually negligible.
Duty cycle. That means that duty cycle will be, as per my experience, it will be 30% will be tramming and 70% will be stable. It's a stationary for the crushing. So
No.
that time the tramming operation will be less. So that's why I asked
The
this
quite a
question.
few applications may having the 50 to 50% of movements. There are different applications where we are having in India itself. There are quarry stable machines are all there. There are the rental application machines are all there. When the rental application machines having those, they are moving frequently, day by day operations they are moving.
Yeah, okay, thank you.
Okay, for using propulsion valves, are you having load sensing pumps
Yes,
Yeah.
sir.
for?
Load sensing.
Yes.
Yeah, we are using.
We are
using load sensing.
It is to have a variable type pump
Yes,
with load
yes.
sensing control.
Yes.
Or you could have also, because you are using electric motor
Yes.
as a prime mover.
Yes.
So maybe you could use the VFD on the electric motor to have different flows. With that also you can control the flow.
Yeah, that can be controlled, sir. The thing is, when we are going up with the VFD, we can operate at the minimum range only. From here, that electrical motor having an example of 50 hertz frequency, we may have to go up to 54 hertz frequency or comes down. That is difficult.
And one more advantage of this propulsion valve will be that they can be operated remotely by a joystick.
Yes.
Either
As a remote
electrical
function.
either an electrical joystick or a hydraulic joystick.
Yes.
That is a very good example where the man can stand outside the machine and he can control the machine very accurately.
Yes.
Yes, it is a good application. Thank you.
Thank you. Yes.
Yeah, the gentleman in the black shirt, please.
Hi, good evening.
Good evening.
Could you have not achieved this same soft ramp up and ramp down by using, meter in, meter out notches on the spool? Apart from the benefit that gentleman mentioned, that
Yes.
this could be operated remotely.
Yes.
With soft meter in, meter out notches, you could
Yes,
achieve the
soft-
similar performance on manual and pilot operated controls also.
Yeah, soft meter and meter up, we can do that, sir. But the thing is, we can't able to regulate the speed. It's in a fixed only. If we are going up with the meter options, meter and meter out, it's in a fixed only when it starts. Here we can able to regulate the speed from 0 to, let's say, take an example of 1 kilometer per hour where the machine moves means we can regulate the speed from start position 0, 0.2, 0.4, 0.6, 0.8. Let's reach up the maximum ramp up of 1 kilometer per hour. The moment reaches 1 kilometer, it starts moving from the 1 kilometer per hour. If we are going up with a meter and meter out, there was a fixed only, right?
That's just for the soft ramp up and ramp down. Then you can open up the notches and get your, step by step, you can get your metering profile that way. Just a thought.
Okay.
Thank you.
Thank you.
Thank you.
Any other question?
Yeah. So it looks like there are no more questions for you, Parthiban and Ravi Prakash. Thank you so much. That was a very engaging presentation. And you have held the attention of the audience firmly in your grip, this being the last session. I'm very happy to see a very engaged and invested audience. And thank you so much for coming here and sharing your findings.
Yeah, thank you, thank you.
Thank you for everyone.
Thank you. Can I ask Mr. Krishnan to give the mementos? Please come to the center.